So here we're going to use our formula that the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So we're going to plug and chug stuff in. They say the probability of A or B is 0.7, and that should equal the probability of A, which is 0.4, plus the probability of B, which we don't know, so I'll call that X, and minus the probability of A and B, which they tell us is 0.2. So now we have your favorite algebra equation. We're just going to clean up this side. 0.4 minus 0.2 is 0.2. So I'll have 0.7 equals 0.2 plus x, just combining like terms. Then I'm just going to solve for x by subtracting 0.2 from both sides. So minus 0.2 minus 0.2, so I get 0.5. Those go away, equals x. And that's my answer. For number 2, they say one card is selected from a standard deck of playing cards. Determine the probability of selecting a jack or a diamond. You are very close. Harsh that she gave you no points for it. You know that there are 12 diamonds and 4 jacks, so you said 16 out of 52. The part you have to be careful about is that you don't double count the jack of diamonds. So the best way to do these is to picture your deck of cards, and you'll take any one of the diamonds, so there's 13 of those, and then you'll take any one of the jacks, but so the ones you circled, 13, 14, 15, 16 out of 52, you had, your answer is actually right. There are actually 13 diamonds, but 12 diamonds that aren't jacks. So the answer is supposed to be 16 out of 52, which simplifies to 8 out of 26, so 2 out of 13, which is what she has. I think she just didn't like the fact that you didn't show the work. She might have been looking for the formulas, because this one, again, your answer is right. One of the balls is selected at random to determine the probability of getting green or red. So you said, like I taught you, that there are 3 reds and 1 green, so there are 4 that you want out of 7 total. And I think that's fine. You might want to ask her about it. She might have wanted to see that the probability of green or red is the probability of green plus the probability of red minus the probability of green and red, which I think is ridiculous. The probability of green is 1 out of, I think there were 3, 4, 5, 6, 7 total. Probability of red was 3 out of 7. You can't get green and red at the same time, so that's just 0, probability of green and red. So then you get the 4/7. So she might have wanted to see that work, or just make it very clear to her that this is what you're doing. You're just saying, these are what I want out of the total. For this next part, though, now you're selecting 2 balls with replacement. So determine the probability that they're both red. So for your first ball first, the probability of getting red is 3 out of 7. And then when you pick again, you picked with replacement, so the probability is still 3 out of 7. So 3 out of 7 times 3 out of 7 is 9 out of 49, and that's what they're looking for that one. So if you're selecting 2 balls, make sure you give them 2 probabilities, one for the first probability and one for the second probability. Multiply them together. Last one, if 2 dice are rolled, what is the probability that the sum of the dots on the dice is a number greater than 6 if the second die is a 4? So if the second die is a 4 and you want a number greater than 6, then that means, like on the second die you could roll a 1, 2, 3, 4, 5, or 6, right? You don't want the 1, because 5 wouldn't be greater than 6. 6 wouldn't be greater than 6. but 7 would be. So you'll take 3, 4, 5, or 6. So there's 4 out of 6 that you want, which is 2/3. So your answer is perfect. She just wants you to show a little bit how. She might be looking for a formula or a chart or just some words, but darn it anyway, your answer is right. So 4, 6, 2/3.